Okay.
跟我们书记说，我们书记在说你再找副书记跟副院长们汇报汇报。
但他就
我这件事情我跟7个人说了，现在的。
那你基本上全都知道了吗？
真的很有趣。唉，
我没有见过这么官僚的了。
对呀、
我知道官僚，但是我没有见过这么官僚。
我这件事情要跟7个人说，太有意思了。
我觉得罗已经吐槽一下了，我觉得，让他也知道这玩意不好弄，跟华能搞不好弄。所以到时候他满怀希望的，到时候碰一鼻子灰。
Okay, so what I taught in my last class was about Gauss-Markov theorem. Basically, Gauss-Markov theorem says that ORS, this one is this one, the best linear, unbiased estimator. This way. Basically here the best means it has the minimum variance. This is what I taught in my last class about the Gauss and Markov theorem. Today I will talk something more about this kind of thing. But this time I will introduce some concept of covariance. So covariance is a measure of the joint variability of two random variables. This one. So in this one, we are thinking about some kind of measure. This time we have two random variables, not one. And basically the covariance is more general than variance. Variance is the measure of data dispersion. In this one, covariance, this one is more likely related to joint distribution. We can think about two random variables. One is x, the other is y. Then we can think about the relationship between two of them. When they are totally random or independent, or both of them are normal variables, then in general there is no relationship at all. Like this. X is random, y is random, x and y random, no relationship. In that case, that is not our point of interest. What we are more interested in is when they have some kind of positive relationship like this. variable x1, x is random, variable y is also random. But when variable x is the positive, then variable y is also more likely to be positive. Then you can think about some kind of relationship. Okay? In this case, when x is positive and when y is positive, when x is negative and y is also negative, then when x increases, we can think y is more likely to be increased. When x decreases, y is more likely to decrease. Okay? We think, oh, there are two random variables or two variables. When they have this kind of relationship, when x increases, y also increase. When x decreases, y also decrease. Indeed, this kind of concept is very similar to OLS. OLS is trying to find out if they have any kind of relationship or not. That kind of relationship is represented as slope of the data generating process, beta. But here, the concept of covariance. When x is positive, y is more likely to be positive. When x is negative, y is more likely to be negative. Then, when you think about this kind of data set, OLS fitting line is more likely to be this one. Okay? In this case, indeed, covariance x and y positive. Okay? We can think about another case. Here is y, here is x, something like this. In this case, when x is positive, y is more likely to be negative. When x is negative, y is more likely to be positive. This one has some kind of reverse relationship. When x increases, y decreases. Then this one is, we can think about covariance of x and y, negative. Okay? So this is some kind of concept about covariance. In terms of mathematics, remember that? What is variance? The measure of data dispersion. Okay? How did we measure variance? Expected value of xi minus x bar. This is mean deviation. Square it. Take average of it. Okay? This is the variance kind of thing. In this case, we squared it because we did not like positive and negative mean deviation cancels them each other. So we squared it and calculate the average. However, here, when you have two random variables, okay, then positive sign and negative sign, they have some kind of meaning. Okay? So when they have positive sign, in this case, we can think about the measure of covariance. This one's indeed this one. Xi minus x bar, yi minus y bar, this way. Oh, I'm sorry. This is the definition of variance. This way. Okay? Mean deviation number 1, mean deviation number 2, we square it. In this case, we are trying to measure how far it is from the mean, and when it is farther to give more weight, we square it. In case of covariance, basically variance is a special form of covariance. This one. When you had only one variable, this is the only variable, negative, positive, mean deviation cancels out. We did not like it in terms of measuring data dispersion. Here, the sign matters. In this case, you can think about this one is y, and here is the average value of y. This is y distribution. This is x. Here is some average value of x here. Okay? Y mean 0, x mean 0 at the same time. Okay? In that case, when this kind of mean deviation is positive, when this one, mean deviation of x is also positive. Okay? So in this case, this way, or let me give you a different example. This is perfect covariance, but anyway, in terms of understanding, x1 equals 1, x2 equals 2, x3 x3 equals 3, y1 equals 2, y2 equals 4, y3 equals 6, this way. Okay? Then, in this case, what we have is this point, and this point. Okay? So we have 3 data points, x and y. We have this kind of thing. Think about these are 2 random variables. Then, what is the average value of x? In this case, 2. Okay? In this case, 4. Okay? Then we can think about mean deviation. x1 minus x bar, that is negative 1. x2 minus x bar, that is 0. x3 minus x bar, this one is positive 1. This one. Okay? Here, y1 minus y bar, that is negative 2. y2 minus y bar, that is 0. y3 minus y bar, that is negative 2. This way. Oh, this one is positive 2. Yeah. Okay? Then, what you can see here is when something, the mean deviation is negative, mean deviation is y is also negative. Okay? When mean deviation is 0, this is the relatively exceptional case. When mean deviation is positive, this one is also positive. Okay? In variance, we squared it to make everything positive. However, in this case, when you multiply 2 of them, this one times this one, that becomes positive 2. Okay? And this one times this one, 0. This one times this one, positive 2. Okay? Here, the sign matters. When you think about something the other way, x1 equals 1, x2 equals 2, x3 equals 3, y1 equals 6, y2 equals 4, y3 equals 2. This way. Let's change it. It doesn't matter. 9, 6, 3. This way. Okay? Then the graph look like 9, 6, 3. This way. Y and x. This way. Okay? In this case, it is decreasing. Then x bar equals 2, y bar equals 6. This way. Okay? Then what is the mean deviation? x1 minus x bar, that is -1, x2 minus x bar, that is 0, x3 minus x bar, that is +1. This way. y1 minus y bar, that is 3, y2 minus y bar, that is 0, y3 minus y bar, that is -3. This way. Okay? Then when you multiply this one and this one, this is -3. 0, -3. Okay? Here, the negative sign means it is decreasing. Okay? This one is the perfect example. But when you think of some kind of randomness, x1 plus epsilon 1, xy1 plus epsilon 2. Doesn't matter. Or 5 and 6. This way. Okay? 1, but there's some small randomness. Okay? These 2, there's some small randomness. Okay? Then here you may think about some kind of this one plus some randomness, but it is more likely to be still negative. This part, there's some randomness, but it is more likely to be still negative. Okay? So this one times this one, anyway, even if we add some kind of randomness, this one increases slightly to here, this one decreases to slightly to here, this one increases slightly to here. But anyway, when we sum this up, we are more likely to see positive value of this kind of thing. Okay? So here, because the sign matters, this kind of sign, positive sign means that they have positive relationship. When x increases, y also increases. Negative sign means negative relationship. So here, the sign is so important. So we don't square it. Okay? We are trying to get some information from the sign of this one. So in this case, covariance, instead of squaring it like variance, we just simply multiply it, calculate the average of it. Something like 1 over n summation I equal 1 to n, xi minus x bar, yi minus y bar, this way. Okay? So in this case, covariance is the average of mean deviation of x and mean deviation of y multiplied. Okay? And then when this average is positive, we think these two variables have some positive relationship. When average of this one is negative, we think these two variables, they have negative relationship. Okay? So, covariance is a measure of joint variability of two random variables. Here, there are two important things. One is the relationship between x and y. Another thing is the relationship between x and error term. Okay? So this is the concept of covariance. Then, let's go back to our OLS. In our OLS, in terms of the algebra, beta hat is summation I equal 1 to n, xi minus x bar, yi minus y bar divided by summation I equal 1 to n, xi minus x bar squared. This way. Okay? This is the beta hat. Then here, if I multiply 1 over n here, and if I multiply another 1 over n here, this one and this one, they are cancelled out. Okay? Then, what is this one? Mean deviation, square it, and sum it, and divide it. This one is variance of x. Okay? This one is related to the variance of x. And what is this part? Numerator. Here is mean deviation of x. Here is mean deviation of y. Multiplied, sum, divided. What's this one? This is covariance of x and y. This is covariance of x and y. So indeed, OLS estimator, when you have some kind of x and y, what OLS is calculating by minimizing sum of squared residuals is the ratio of covariance of xy divided by variance of xy. Okay? That's the meaning of or interpretation of OLS in a simplest way when we do not teach partial derivative and what? Partial derivative, chain rule, and those kinds of things. Okay? This is OLS. Then, and this one, we can say that OLS estimator is covariance of x and y divided by variance of x. What does the covariance mean? X and y, do they have positive relationship or negative relationship? When covariance is positive, they have positive relationship. Then beta hat is positive. Okay? When covariance is negative, they have x and y, they have negative relationship. Okay? Then covariance is negative. Okay? So this one, this part of covariance, it determines do they have positive relationship or negative relationship. Okay? Sometimes it has positive relationship, sometimes it has negative relationship. That's one thing. Another thing is we need to normalize. Okay? How do we normalize it? When x increases by one variance of x. X is about data measurement of it. Okay? When the value of x increases by one variance, then what happens to the covariance? Okay? When variance is small, then when x increases just by one standard deviation or one variance, this one will be very heavily impacted. When variance is really big, okay? When x is really, this is the kind of thing x. And then when the variance is really big, this is different from very compactly related x. Okay? So this one, x and y, they have some kind of covariance, positive or negative relationship. We need to standardize it. Then how can we standardize this one? By dividing variance of it. So this one is something like this. When you have this kind of relationship, you can think about some kind of variance of x. Okay? When the variance of x increases by 1, then what happens to covariance of y? Okay? That is basically the concept of the slope. When x increases this way, how big the y increases? Okay? That's the concept of slope. Y equals 3x plus 1. This means that when x increases by 1, y increases by 3. This way. Okay? When this x increases by 1, we think the value of y will increase by 3. That is the concept of the slope. Okay? This one is talking about when variance of x increases by 1, what happens to the covariance of it. When the covariance of it is positive, it has positive relationship. And when the covariance is negative, it has negative relationship. But in terms of how much does the x increases, standardize it by the level of variance. That is the concept. Okay? So in this way, OLS is basically trying to calculate the ratio between covariance and variance of it. When this is kind of thing. This one, when the variance of x increases by 1, what happens to the covariance of y? Divided, that becomes slope of this one. Okay? So this is some kind of intuition. This is one thing. Another thing is, when you understand something like covariance of this one, you can think about something else, that is covariance between x and epsilon. In this case, summation I equal 1 to n, 1 over n, xi minus x bar, epsilon I minus epsilon bar, this way. Okay? This is covariance of this one. The main assumption of OLS is this x variable and error term, they have no covariance. This is main assumption of OLS. Okay? When I write down this one is the same as epsilon 0, this one is 0, so this is yi minus alpha hat minus beta hat xi, this way. This is epsilon I. Okay? Times xi minus x bar. I told you this kind of x bar is sometimes negligible. Times xi. Let me write down this one here. 2 times negative summation is, this one is the OLS condition for the second variable. yi minus alpha minus beta xi square sum it, take partial derivative with respect to beta. Then you will get summation I equal 1 to n, 2 times yi minus alpha minus beta xi times negative xi, this way. Okay? Delete 2, delete negative 1. Think about this one as epsilon I. Okay? Then this one is very similar to covariance between x and y. So here, the most important assumption in OLS is covariance between x and epsilon is 0. This is the assumption of OLS. Later, when you run something instrumental variable, This is usually called IV. This one, do not assume this. So that's why this one is more advanced technique. ONS is based on this kind of assumption. Okay? IV relaxes this assumption. No, that's not the case. Then what should we do? That kind of thing. But anyway, at this moment, I will teach this one later. What you need to understand is this is the assumption of OS. Error term and X, they are not related. Okay? In that kind of thing, we can think about in terms of covariance. This one or this one. Okay? So this is the concept of covariance. OLS is basically covariance divided by variance. Okay? This is one relationship. And when you understand this OLS is related to the variance and covariance of it, multiple regression becomes relatively more understandable. So, this time, let's talk about multiple regression. Up to now, what I taught was something called simple regression, that is yi equals alpha plus beta xi plus epsilon I. X and y, simple relationship. Okay? In case of the multiple regression, what I have is something like yi equals alpha plus beta 1 x1i plus beta 2 x2i plus epsilon I. This way. So in case of multiple regression, you have one x, another x, here is y. Okay? So two x's are impacting one y. So in this case, the way is the same. Here what we are trying to do is minimizing sum of squared residuals yi minus alpha minus beta 1 x1i minus beta 2 x2i. This is our residual. Scale it, sum it, minimize it with respect to alpha, beta 1, beta 2. Okay? Then what's the difference? We have this kind of thing, summation I equal 1 to n, yi minus alpha minus beta 1, x1i minus beta 2, x2i, square, take partial derivative with respect to alpha. Okay? Then this one, summation I equal 1 to n, yi minus alpha minus beta x beta 1 x1y minus beta 2 x2i. Two times negative 1 here, summation I equal 1 to n. This one equals 0. Okay? Any problem? Next one is partial derivative I equal 1 to n. yi minus alpha minus beta 2 x2i minus beta 1. Sorry. Beta 1 x1i minus beta 2 x2i square, take partial derivative with respect to beta 1 this time. Okay? Then what you have here is summation I equal 1 to n. 2 times yi minus alpha minus beta x1i minus beta 2x beta 1 x1y beta 2 x2i minus negative x1i equals 0. Okay? Question? The third one, summation I equal 1 to n, yi minus alpha minus beta 2 x2i, x1i. Why am I keep saying beta 2? Square, take partial derivative with this beta 2, summation I equal 1 to n, yi minus alpha minus beta 2x beta 1 x1i beta 1 x1i minus beta 2 x2i minus x2i this way. Okay? Then I can delete this 2 and negative 1, this 2 and negative sign, this 2, oh I even did not write this one. Okay? Then if you are familiar with this kind of, did I just delete it? Covariance that I wrote it down here. Okay? What is this one? This one is epsilon I. This is epsilon I. Then what is this one? This one is covariance between epsilon I and x1i equals 0. Okay? This one means that covariance between epsilon I and x2i equals 0. Okay? In case of simple regression, we have one condition that is covariance between xi and epsilon I equals 0. This time we have two variables. The first way is this one. Covariance between this one and this one is 0. Covariance between x2i and this one equals 0. This is sum of epsilon I that equals 0. Okay? This is one thing. Then, 3 equations. Three unknowns. You can solve the system of equations. Okay? This is one way. The other way, in terms of matrix, okay? What you have is y1, y2, y3, this way. 1, 1, 1, x1, 1, x1, 2, x1, 3, x2, 1, x2, 2, x2, 3, this way. The first one means that first variable of x. x2 something means that this 2 means that second variable of x. Okay? This is development, this is education, this is institution, this way. Okay? Then we here have alpha, beta 1, beta 2, plus epsilon 1, epsilon 2, epsilon 3, this way. Okay? Then this is our X matrix, this is our Y matrix, this is our B matrix, this is our E matrix. Okay? This is our X matrix. Then what is our B hat? X transpose X, inverse X transpose Y. Okay? So in case of matrix, the same. Simply you add one more line here. Then matrix will solve it. When there is one more regressor, one more line. Okay? This is why the matrix version is way more prepared. However, in this time, I need to teach something in terms of algebra. This way. Here, OLS is very frequently used. Mainly because in this kind of multiple regression form, x1 impact y1. Okay? x2 also impact y1. Okay? But the problem is that in many cases, when x1 increases, x2 also increases. Okay? This is development, this is education, this is institution. When we increase the level of education, okay, this one will itself impact development. That's one channel. Okay? Here, development is impacted by institution. Okay? That channel is this part. Okay? Then, institution, when you're out, I'm sorry, this one is what I have here, education. Education impact development, this part. Education impact development. The other channel is education can impact institution. Okay? Then institution can impact development. When you increase education, education directly impact development. Education also indirectly directly impact development. Education also indirectly impact development. Okay? That is possible. There's another case, that is, here is development, here is institution. Institution directly impact development. When you increase institution, this one impact education. Better institution makes better education. Better education impact development. Institution itself impact development. Institution itself impact education, and education increase due to institution impact development. Okay? So there are two ways of impact of institutions. Direct way, indirect way. Okay? There are two ways of education, direct impact, impact through institution. Okay? One simple solution, okay, forget about this one and forget about this one. The life is simple and beautiful. Okay? That's the general response. However, when you say, okay, there are two ways of impact of education. Institution directly impacts development. institution impact education and increase education due to more institution impact development. We considered both cases and get final impact of institution. This one sounds much more scientific. Okay? One way is, hey, forget about it. What is the best part of OLS? OLS is doing this entire thing when you calculate it. That's why OLS is so popular. In terms of matrix, X transpose X, this matrix is doing that kind of thing. Okay? So this part is a little bit more complicated, but I'm giving you the intuition first. Okay? Here, one dependent variable, this one directly impacts this one. This one, increased education, increases some part of institution. Okay? Institution increase due to more education, and this kind of increased institution due to education impact development. Then we can think about two ways of the impact of education, direct way, indirect way. But total impact of education in terms of scientific way, we need to consider direct way and indirect way at the same time. Indeed, in science, they are doing this kind of way. In case of OLS, mathematics is doing those kind of things. Okay? Then how does the OLS is doing? Wow. Yeah, let me explain this one in terms of matrix. That's always better. Did I delete it? But anyway, our X matrix is 1, 1, 1, x 1, 1, x 1, 2, x 1, 3, x 2, 1, x 2, 2, x 2, 3. This is our X matrix. Okay? This one is education, this one is development. Okay? Then what is X transpose matrix? X transpose matrix is 1, 1, 1, x 1, 1, x 1, 2, x 1, 3, x 2, 1, x 2, 2, x 2, 3. This way. Okay? So this line is education and this line is development. Okay? Then X transpose X matrix is so important. This one, when you calculate it, oops, I need quite long one. 1 times 1 plus 1 times 1 plus 1 times 1. That is 3. The number of observations. Okay? Then what's the next one? This one times this one. Okay? Here, what you get is summation. I equal 1 to 3. Let me x1 I. This one. Okay? This one times this one, what you have here is summation. I equal 1 to 3 x2I. This way. Okay? This one times this one, what you have is summation x1I. Okay? Here, what do you have? This one and this one. Summation x1I squared. And how about this one? here what you have is summation I equal 1 to 3 x1I times x2 this way. Okay? x11, x21, x12, x22 that way. Okay? This one here, what you have is summation x2I. Okay? Here, summation x2I, x1I. Okay? And then finally, summation x2I squared this way. Okay? Then what is this one? And how about this one? This one is summation of x1i. This is summation of x2i. This one is x1i squared. The variance of xi is related. Okay? This one is x2i squared. The variance of x2 related. Okay? OLS is about the relationship between covariance and variance. Okay? And here, what is this one? Covariance of x1i and covariance of x2i. Okay? And we need to take this one x transpose x inverse. B hat is x transpose x inverse x transpose y. Okay? Okay? Then this one, what we need to do here is inverse of this one. Inverse of this 3 by 3 matrix. Okay? I did not teach it. It is a way more complicated than 2 by 2 matrix. Maybe you may have learned it and forgot about it. Basically, you write down these two rows here, and this way, this way, this way, and this way, this way, this way, subtract it, and delete first line, second line, like 2 by 2 matrix. That is something called cofactor expansion. You need to learn it. Okay, I can teach it, but it is not very frequently used if you are only interested in understanding OS. But anyway, what I can say is, when you take inverse of this matrix, okay, inverse of this matrix, this covariance part comes in. Okay, you need to think about not only the variance of x, but also covariance of this one. Okay? And this one, in terms of matrix operation, it will make you to think about variance of xy and covariance of xy. In this kind of covariance, when x1 is increasing, what happens to x2? There is covariance between x1 and x2. When education increases, what happens to institution? In general, we think when good education will lead good institution. Their covariance is, in general, we think positive. Okay? Then there are some effects of education. Education impacts this one directly, and education also impacts this one, institution. Covariance between education and institution is positive. When you increase education by one level of standard deviation of education, okay, then it will also impact the degree of the level of institution. Okay? That part is covered by this one in this X transpose X matrix. Okay? And then it will take calculation of it. And another thing is this part, This is our X matrix. 1 X transpose 1 1 1 X 1 1 X 1 2 X 1 3 X 2 1 X 2 2 X 2 3 Y 1 Y 2 Y 3. What is this one? First thing is summation yi. Okay. Second part is summation x1i yi. The third one, summation x2i yi. What is this one? Covariance of x and y. In this case, covariance of x1 and y. Okay? This part is covariance of x2 and y. Okay? So this part, what is this part? Covariance of x1 and y, covariance of x2 and y. Covariance of x and y. Okay? This is simple regression, this is multiple regression, but the concept is similar. Covariance of x and y plays some role here. Okay? And then this one should be divided by variance of x. Okay? When you consider the variance of x, that is this part. This part. Okay? But here, because you have x1 and x2, this kind of covariance also impact this one. Okay? When x1 increases, here, yeah. When education increases, it directly impacts development. When education increases, it impacts institutions through covariance of this one. Okay? This one is related to covariance. That part is this one and this one. Okay? This is the simplest intuition that I can give you about multiple regression. But what you need to remember is this one. OLS is taken care of this way and this way. Okay? That's why OLS is so popular. Okay, just a moment. I think let me stop my today's class here. Try to understand what is covariance and this kind of thing.